Good morning, and welcome to BSides 2020 in Tampa. Today's presentation will be Breaking NBAD and UEBA. The presenter for today's presentation is Charles Herring. With that being said, Charles Herring.
Thank you. Appreciate it. All right, so you can grab the deck here from, that takes you to my LinkedIn page. You can download it. I have the Pastebin scripts are also on that link. A little about me, then we'll dive into, I'm going to try to do a live demo today. I did this talk at DEF CON earlier in the year and wasn't brave enough to try a live demo on their Wi-Fi, so we'll do it here today. A little bit about myself. I was in the Navy from 95 to 2005. The first part of that, I fixed F-18 Hornets. I was an electronics technician. After 9/11, they detailed me to the Naval Postgraduate School in Monterey, California, to stand up the network security group and start working on operationalizing security inside of the Navy and DoD. I was also a founding member of the School of Root. So if you watch Silicon Valley, Guilfoyle says no one's going to break in here. Not the nation state of China, not the School of Mother Root. So that's our team. We've won so many times we can't compete anymore. So those were the good old days at DEF CON. I did magazine reviews or product reviews for InfoWorld Test Center up until journalism died and the test center shut down. Went to work for doing consulting work for 7 years with DoD. The time I was at the Naval Postgraduate School, we did a lot of research around anomaly detection, or what's now called machine learning. Went to work for a company called Landcope, which came out of Georgia Tech. It's acquired by Cisco. Then 4 years ago, I started research at WIDFU. So before I get started, I'm going to fire up a part of, I might have to hold this thing. I'm going to get started on it. Yeah, that's better. On the demo. So I'm going to attack my own product today to save me a cease and desist letter. So we have one incident here with a handful of leads from TrapX, some firewall blocks, Symantec endpoint. I'm going to show you. This is the attack, and I'll come back and we're going to explain this. It's going to take a little bit of time to run, so while the attack's running, we'll do some slides and come back to it later. But essentially what this script is showing, and this is the script is on Pastebin, is we set a couple of date formats. This is the destination that I'm going to send these garbage logs to, which is in this case, my SIM product, my logging product. And then I'm going to randomize the attacker's IP address in the message, so that this is, we'll get to a mass implication, but this is basically poisoning all the data inside of the logging aggregator so that it's useless. So let's run that. Do your work. All right. So we're going to hit on what is NBAD, what is UBA, how does it fit into SIM or log aggregation detection. We're going to go over what poisoning, non-repudiation, then we'll get into the attack techniques and attack scenarios. I really do suggest you download this. There's a lot of code in here, so most of the stuff is command line code you can run to generate this stuff. So just real quick, Dr. Dorothy Denning in 1986 wrote a paper called Intrusion Detection Expert Systems at the Naval War College. And she looked at how do we detect anything, how do we detect any attack, and it boils down to really three categories. A signature-based detection is when we're inspecting an object, like a packet or a file, for something we know is bad. So after I get out of the session, I'm going to the bar, I'm going to order a beer. If there's mold in my beer, I'm like, mold is bad, I'm not going to drink the beer. Actually, I'll probably still drink the beer, but the mold is bad. So that's signature detection. Behavioral detection is you observe the behavior of the subject after it ingests the object. So the file's executed inside of a machine, and all of a sudden it starts encrypting the disk. Well, you might not know that the file was bad, but you know the behavior that followed the execution is bad. So that's behavioral-based detection. And then anomaly-based detection is building a baseline of what is normal, what things we know are normal, and when do we deviate from normal, so that's anomaly detection. And the way these things fit together is anomaly detection helps us create net new behaviors to look for. And behaviors help us create net new signatures. Signatures have the benefit of having certainty of what they are, so they have the lowest false positive. They also have documentation behind them, CVEs and that type of thing for responding to them. So they're very good for known exploits, obviously not very good for O-Day, zero-day unknown exploits, and not very good for exploits that aren't that aren't exploiting vulnerabilities, things like credential abuse. Someone that's used is like an Edward Snowden type of attack. There was nothing to detect. The guy had access and he abused it. When we're talking about baselines and anomaly detection, the first thing you have to understand is, what are you baselining? Do you baseline the entity, meaning does every host or every user, every file have a baseline, or do you create a cohort? And so a peer group would be all the hosts on guest wireless could be a baseline. So you baseline the sum of those hosts as opposed to baselining each individual. And that tends to have the benefit of any single bad actor deviating from normal won't mess up the baseline. So you have some safety in numbers that way. It takes time to build baselines, and so supervised machine learning is when you establish what variables you're going to baseline, such as how many bytes are transferred per day, on user anomalies, how many, what time of day people normally log in from HR or so forth. And unsupervised is you just let the machine figure out all the possible variations and build out profiles that way. Network behavioral anomaly detection came out around 2002, and the data source tends to be NetFlow, IPFix, some type of metadata concerning packets, because building baselines is volumetric. How many bytes were exchanged, how many relationships, how many SYN packets versus SYN-ACKs, and those type of things. And all of that's really in the TCP header. So metadata like NetFlow became a really powerful source of baselining what's going on in the network. And because it's coming off the route switch infrastructure, you could do it laterally. You could look at the stuff moving between segments inside of the network and not be limited to egress points. Yep. Here's a list of some tools. This is from Gartner on things that do that. I think most of these are still around. So when you're looking at NBAD, what type of anomalies are we looking for? One is service traffic threshold anomalies. So a host that's expected to consume less than a gig of web traffic consumes 20 gigs. That's an anomaly. Why did it just consume 20 times what was expected? Same thing with service type. If a new service comes up in a subnet that only has web services and now it's hosting onion routing or it's hosting DNS, that's a new type of service type. Geographic traffic anomaly is we always get during these periods of time, we only get traffic from the following geos on the globe, ASNs belonging to the following geos, and now we start getting a lot of traffic from Iran or China or somewhere else. Data hoarding is a really cool anomaly detection thing in network behavioral anomaly detection. Essentially what you do is you figure out how much internal data is transferred to each host inside of the network. So host A is expected to consume less than 100 megs of corporate data in a day. So when it consumes 10 gigabytes of data, it's of extreme concern, because normally that type of anomaly would be associated with data theft, that someone's trying to hoard the data, put it on a thumb drive, and walk out. And it's really easy to catch that using network behavioral anomaly detection, because you're counting how many bytes a given user or a given host is taking in. Same thing with data disclosure. If you have huge amounts of data leaving the network from one host, that's also something you detect by building out baselines. When you get into user and entity behavioral analysis, for those of us that have been doing this for 20 years now, we used to do incident response on alarm rows. Snort or firewalls would generate an alert. We would investigate that alert, and we never got to the bottom of that list because they came in much faster than we could respond to them. Then we pivoted over to host-based investigations, where we took all of the alarms, we associated them with the computer host that generated or were connected to those alarms, and we investigated the host. Then we pivoted to user-based detection later on, which became the basis of user and entity behavioral analysis, to where we have a user, he's on 3 different machines. We take all of those alarms that are aggregated there, and it becomes an aggregation layer at the user. So really, most of UBA is pivoting around user behavior, and we're baselining different things that the user does. There's a long list of different things that do that. One of the most common is magic carpet attack. So if someone logs in from Tampa in their machine and then 30 minutes later logs in from Tehran, that doesn't seem likely that they can cover that kind of distance in that amount of time. So that's that's a geographic anomaly. Also, how often do they log in to geos outside of southern Florida? Time of day. When do users normally log into their machines? When do they normally access different types of data, and so forth? What host do they access? If they're only hitting email and SharePoint, why are they now all of a sudden trying to access security tools or firewalls or those types of things? So with that boring part out of the way, let's talk about how to mess it up. So there's a few ways of poisoning data. And when I say poisoning data, these are going to be used when you're doing some type of attack. You intend to exfiltrate data, or you want to disrupt services, but you don't want to get caught. So these are going to be the techniques we use to do that. So we have mass implication. We're going to go over baseline boiling, attack masking, and then the methods for generating those logs will be through log spoofing, behavioral spoofing, and where we do it. So this is a screenshot from my thing where this was a data exfiltration at a large university on the left. And so our goals are either to make all of those alerts disappear so that they never show up in the system, or we make it completely useless where everything is attacking everything and you can't discern what is real and what is not real. So quick note on how to prevent this from happening in your organization. One, wherever possible, do logging with client-based authentication via PKI so you know where the data came from and it was verified through a handshake. IP spoofing protection. If you're using Cisco gear, that's the iOS command to do reverse path checking to make sure that for instance, if you're sending a UDP packet, you can lie, right? You can say you're whatever in the header, whatever IP source you want to. This command has the route switch infrastructure checked to make sure that's possible, that you really are that sending host. Protecting the security infrastructure is very important. How data flows in to your logging systems, your analysis systems is critical. So doing microsegmentation or using something like TrustSec to take care of that. And then sort of the last, two more points. The last thing is honeypots, deception technologies are really good when everything else fails. Things like TrapX and just any honeypot, because if someone's talking to what's supposed to be a non-existent host, that's going to give you a lot of clarity when everything else fails, particularly in spoofing. And then chain of custody tracking. As you're bringing data in, treat it as evidence. What port did I receive it on? What machine received it? What was the protocol? All of that should be in the metadata when you're processing data. So if you are poisoned, you have some mechanism for filtering out the things that were poisoned. So all the attacks we're going to go over here in a second are, they cover everything except initial access from the attack MITRE, from the MITRE attack continuum, but initial access needs to exist. So a common technique I use is the pump and dump. So you can either use Docker. I most commonly use Docker to do this. You can use a VM if you wanted to. But essentially, you set a manual MAC address on your container. I'll show you the commands to do that in Docker in a second. I normally choose to get an IP address via DHCP, so the architecture is issuing me a new MAC address, a new IP address against the MAC address. I should say attack, not attach. But perform whatever attack you're going to do. If you want to do recon, you scan some segments. Release the IP, so do a DHCP lease release. Swap out the MAC address on the box and continue your attack. So normally I do these about every 2 minutes. So the machine's IP address is constantly changing. So when they're trying to find me, it takes a lot longer for them to find me on the network. And of course, if you're doing some access layer logging, this is one great way to catch it. So if you're an access layer monitoring the MAC address that's connected to the port. You can get there much quicker to preventing the pump and dump. So this is how it runs. This is the command for the first thing's for spinning up a Kali Linux Docker container with a static MAC address. So it's just broken down to create a network on the host. So this maps to the host NIC. You're setting the MAC address, and then by default, it'll do DHCP with this version of Kali, and then the container is called Kali1, and then you start it. Then you have a bash command, do your stuff, kill the thing, and then spin it up with a new MAC. And there's nothing keeping you from having several of these running at the same time so that you can compress the attack window. Another one is what I call a pocket dimension, which is where you create a fake internet. So you can make any traffic appear to occur even though it didn't really occur. So if you're plugged in, even on wireless, and the wireless is doing access layer NetFlow in particular, or there's some other type of logging with probes and that type of thing, you create one host that is maybe inside. You can create Google servers and Azure servers outside that have those public IP addresses, and you attack them in this little fake network. Well, as you're attacking them in the fake network and you're mapped over to the access layer is going to generate telemetry as if that was really happening. So it looks like you just tried to attack a server that's outside the network, but you didn't, right? But it does create the record. So the architecture starts generating all of these records. So very simple to do that. In Docker, you're going to create a bridge network. So you're going to take your physical NIC, bridge it to this fake network that I called nothing. I didn't name it. Network Pocket. You create a network called Pocket, and then you add these hosts to that network, and then as they attack each other, as you're running these fake attacks, the telemetry is being generated into the network based on the existing logging infrastructure. So the more direct way of faking things is just spoofing the logs altogether. Most systems collecting logs collected over UDP, syslog 514 UDP is the most common way. If you can find where the logs are supposed to go, in a lot of organizations it's logs.corporate.com, so it's not generally too well thought out. So you can try that first. And just directly send messages, whatever message you want, which I'll show you in a minute, to create the fake evidence. So you don't need an expensive tool to forge a syslog message. It's Netcat. So any message you want, you can find the formats for different tools all over the internet. You just put together your message that you want to send, pipe it to Netcat, with the server's IP right here on 514, and now the server thinks something happened that really didn't happen, and you can tell the server anything that you would like to tell it. When you don't know where the log aggregation is, you can use an approach I call it a UDP Spray. So there's a great project on GitHub called Samplicator. And what it does is it takes in UDP packets, and it can send those UDP packets to multiple destinations without mangling the header. So it'll masquerade the source IP. And so you can dump in basically an entire class B of IP addresses, send the packet into the listening port, and then it'll send it out to every one of those destinations. And so one of them will be the logging server. So very simple to set that up so all these attacks can work through the UDP Spray. This is a script for connecting to TLS. This is syslog over TLS connection. So this one requires a little bit of crypto. So this is a Python script you can use for doing the same thing. It's just you got to do a TCP handshake, do a TLS handshake, and then you can ship your messages. Another way is if the architecture or the security infrastructure is not generating logs when you do a pocket dimension, you can generate them yourself. So you have a fake network where you're going to run fake attacks. You can execute nprobe, so you can grab that from ntop site, run nprobe on the machine, and configure it using the command there to send all of the observed traffic to the NetFlow collector. So you could also use UDP Spray here to send it everywhere until it hit a NetFlow collector. So essentially, this allows you to generate your own fake traffic in situations where the architecture will not. And last technique here is if you have things like Elasticsearch or Splunk that you're trying to send messages to over a REST API, curls your guy right there is how you send it to. This is an Elasticsearch example. All right, so now let's do some of the attack scenarios. Mass implication is when I'm running an attack and I want everybody else to look guilty. So it's not going to erase that I did it, but I'm going to make it look like 10,000 other hosts just did the exact same thing I did, so the incident responders don't know which one of us are real and which one of us are fake. So the script I just ran a second ago does this because I know the destination of the collector, so we'll look at the results of that in a second. But essentially generating bad traffic that has a lot of attacking hosts. So you can pick several class Bs of internal IP addresses and ship those out. Yeah, I'm not going to do that one. Okay, and then let's talk about baseline boiling. So we can use these same techniques to screw up a machine-learned baseline. And so the way that we do this is you pick what baseline you want to mess with. The most common one I like to mess with is time of day and geographic user logins. So the systems that do these things are building baselines over time. So if you have a small deviation, it's not going to generate an alarm. And so what we'll do, if I'm looking at data hoarding, for instance, I'll pick all of the users that I can enumerate from Active Directory, and I'll create a log showing that they downloaded a little bit of traffic, 100K the first day, and then the next day 200K. And then after eventually you blow it up to where the baseline is now in the gigabyte, so it doesn't even matter what you do in anomaly detection because you slowly boil the baseline beyond limits. Same thing on time of day. Just create one log entry for one user every once in a while that's a little bit later, right? If it's normally 4 o'clock, to start moving it to add a 4:05 login. That's not going to throw off an alarm. Next day 4:10 and so forth. So you can keep rolling these things out to where everybody's logging in all the time from everywhere. It's changing the geos. So it boils the baselines to where they become useless. Very common for red teams I work with to do this over a long period of time in a pen test. And so that's that piece. And let's take a look, see if my script ran. And so now if I refresh this, we had the albatross. This is what I get now. So this was that simple incident we had before. It looks like this. So it poisoned it to the real incident. Now has a bunch of fake data in it, fake attackers, fake user accounts, fake destinations, and it's hard to even figure out what this is supposed to be. I have 541 alarms associated with this instead of the 9 that are supposed to be here. And then I have a long list of additional incidents that were generated. And I like to pride myself in reducing noise, but this is everyone's vulnerable to this if you don't control how the data comes in. And so the one real attack's hidden in there, and we have a bunch of these fake attacks that have been created as well. So which one of these? There's only one machine that's actually bad in this mix, and now we have, what did it say here? What did we do? We spoofed 1,753 attacking hosts. So IRs, one of those is real. There's 1,754 hosts to investigate, and only one of them is a real attacker. And so that's going to take a lot of time to sort through what to do there. So, just reviewing again, the way to remediate these things is control how your data comes in first, do authentication, control the pathways that the logs are taking to come in, both in NetFlow, syslog, protect access to the APIs providing the data, enable spoofing protection on those pathways that are bringing it in, segment, protect the security architecture, and if you don't already have a separate logging architecture from a separate subnet that has its own ACLs for egress and ingress, that's really important to do to avoid a lot of this. Obviously, obfuscation, which we saw earlier. Don't name your logging server logs.witfoo.com. That's just too easy. Again, honeypots where you can put them out will sort of be, if you run into this, will help you catch the real attacker, because if I'm doing a recon of the network, you actually will get a hit inside the honeypot. And then this chain of custody. Inside of the system I use, QRadar is good at this as well. Splunk has a piece where they tag how did it come in, right? How did I receive this record? Did it come in over what machine received it? What IP address? What port was it listening on? What protocol was observed? So that if you need to go and filter out records, you can filter out the things that match the conditions of the poison data. So with that, I will answer any questions. Whew. Someone's got to ask me a question. No, nothing. All right, well, I'm on the bar then. All right, last call. All right, you may applaud. But you can download all the scripts and stuff from my, they're on the blog, but they're also on my LinkedIn, so grab them, ping me if you have any questions. Yeah, go ahead. Mm-hmm.
So are you saying that you just continually smash that traffic out there, or are you eventually detecting when that log server?
You'll never detect it. Yeah.
So you just continually spoof or
Yeah.
send all those fake logs to every single IP up out before, and hoping that you hit one of these logs.
That's right. You'll hit one of them if there's a pathway to it that wasn't mitigated against. So you don't have to know. It's a downside to UDP is he doesn't know who you are, but you also don't know if the message made it. Yep.
Are you mostly doing this from a machine that you plug into a network, like going on site? Or are you mostly doing this from like a VM on their infrastructure?
It can be any of those. So any access. Most commonly, it gets done on guest wire. So the question was, where do you put the machine that generates the traffic? And it can most commonly be on a wireless network because it's the easiest thing to get to. And if they're doing monitoring on the wireless network, it's still going to generate telemetry, and the telemetry is not smart enough to know that it should only be generating telemetry about the wireless network. So you can generate telemetry about anything, and it's going to go back to the system. So generally, spoofing, if you can find the logging server, that's nice. But even if you can't, if the architecture has been set up with probes or NetFlow or other logging solutions, it's going to generate traffic for you. So you just sort of have to insert a whisper campaign, right? You're whispering bad information to the architecture, and then the architecture reports it back to the reporting systems. Is the easiest way to do it. When we do a pen test, we have some idea because we can see how much sweat starts coming out people's faces, that whether or not it's getting there or not. But if you're an external attacker, you generally don't have that. Then botnets are also good. So once you have initial access, you can do it anywhere. But most commonly, if you have physical access, you just come in and drop in on a wireless access point. All right. Well, thank you very much. I'll be at the bar.